This video is meant to remind you about the similar triangles and how to solve them. We're going to look at 3 different situations. So one where we've got the angles like so, parallel, and when we've got the right angle triangles. Start with the first one. We've labelled the points, the vertices, and then the first thing we need to do is actually prove or determine if there are similar triangles in existence here. You can see we've got one pair of angles that are the same. We just need one more pair to prove that they are equiangular, and we can see very easily that this angle here is shared or common, and therefore if we've got 2 angles that are the same in each triangle, the third has to be the same because 180 degrees in a triangle. Now we just write that up. We would say that angle BAC, so this one here, BAC, is common, and we've got angle ABC equals angle AED, and that was given to us. Therefore we've got equiangular triangles in existence, which means that triangle ABC is similar to triangle AED. If you want to give a reason, the best word in the world, equiangular. So now we have to decide the ratios, because it's really important. If you can nail this bit, the rest is just simple algebra. One of the tips is when they're drawn like this, where one is rotated from the other, my tip is draw them separately, and it doesn't take long. You don't have to label the whole ABC as long as you get the angles in there. So if I draw my small triangle here, as long as I make sure that that's the beta, that's the dot, and I say, yep, that's 7, and this is x take 3, we're nearly done. We now draw the bigger triangle. Again, I'm not really phased about incredible accuracy here, but I am wanting to make sure that I've got the angles labelled. Now, this whole length here, we can see clearly is x take 3 plus 5, so x plus 2. And this length here is x plus 7. So apart from being able to see your information really clearly, it also helps you avoid making mistakes, because some people would maybe think that one length was just x, not actually x plus 7, and that's where an error occurs. Okay, now we can see that we've got B here is opposite, we've got B, its opposite length here, the blank one here is opposite 7, and the blank one here we've got the x plus 2. So now we're going to do our ratios. Let's get my pen back. Normally you start with the unknown upstairs, but in this case we've got unknowns all over the shop. So I'll start with this one, and I'll go, well, that's going to be x take 3 over 7 equals, now it's not a guessing game, x take 3 is opposite the beta, so on the right hand side here I will also start with x plus 7 because it's opposite the beta there. All over. Now double check, always double check, because I might be sneaky and put in a third side, and so it's not again a guessing game. Which one do I pick? You've got to make sure they match. So here the blank is 7, so here my blank angle is equivalent to the x plus 2. And once you've got that, that's the hardest part done. Now it's just a simple matter of solving. We're going to cross multiply. So x take 3 times x plus 2 equals 7 x plus 7. We'll expand all of that. We end up with x squared take x take 6 equals 7x plus 49. As soon as you see the squared here, a quadratic, we know we want to get everything on one side. And once we do that, we take a moment to see, are there 2 numbers that times together? Give me 55, add up to -8. Can't think of any at the moment, so then it's either quad formula or to the calculator we go. You should remember we just go into equation. We are going to go to polynomial degree 2, enter, so it's 1x squared, take 8x, it's already there, amazing. Solve, we get two answers, but we will disregard the negative because we're talking about a length, so x is 12.43. We'll go with 12.43. So we can now say, therefore, x equals 12.43. Don't forget to put your centimetres. Check, is it a reasonable answer? Seems good. That's done and dusted. Let's try the next type. So again, when we're faced with a question like this, the first thing we need to do before we get into the ratios is prove that they're similar. And we can see the parallel line, so hopefully you're all thinking corresponding angles, which means that this angle would have to be the same as this one. You've now got a choice. You could also say that these two are corresponding, or you could say that this angle is shared. Your choice. It's up to you. I'm going to go with the shared one because I've already written it in. Again, we write it up. So angle BAC is shared or is common. We've got angle ABC. So ABC equals ADE. You have to give the reason, please. So corresponding, you cannot just put because the parallel lines. It needs to be the correct thing. So corresponding, alternate, or allied, but not just parallel. You will lose a mark if you just do that. And therefore, we've got triangle ABC is similar to triangle ADE because once again we've proven that they are equiangular. Okay, from the previous question, remember the tip was to make sure that if you're unsure of what the lengths are, draw them separately. In this case, the triangles aren't really rotated, so I can see quite clearly. If I start with my unknown up here, that's going to be x over 5. And I'd always double check, so I go x is opposite beta. So for the big triangle, it's going to be 11 divided by now. This length here, remember this was opposite your blank angle. Opposite the blank angle here, it's not just x, it's actually x plus 5. And that would be where I see a lot of errors where students would just put x. So make sure it's the whole length of the triangle. Once you've got that, hard part's done. Cross multiply, x times x plus 5 is x squared plus 5x. 5 times 11 is 55. Lo and behold, quadratic again. Bring the 55 over. Doesn't seem to be able to be factorized, so I'd go to the calculator, or you can use your quad formula, and you should get an answer of, I will just do that on my calculator here, and I get an answer of 5.33. So you check that on yours, see that you get the same. Okay, and remembering if you can do it several different ways. If you decided, some people, I like to always go take the small triangle, look at their ratios and then get it from the big, but if you wanted to go just the common sides, so the corresponding sides, so if you went x over 11 and did that, so that would be x over 11, and then you started with the small, so that would equal 5 over the length of the big triangle, which is x plus 5. Once again, when you expand this, you get the same line. So it doesn't matter which way you do it as long as you have the correct corresponding sides. If you mix these up and you put the x plus 5 over 11, that's wrong. So it's not close enough is good enough. You've got to be precise. Last type of example. We won't go through, we'll just explain the proof. You can see, are they similar? So I've got the 90 degrees here, and once again we've got a common angle. So we can say, yes, we've got similar triangles. Now, when we go to do our ratios to find out, you can see here that I've got on my small triangle, I've got 5, and I've got the length that's opposite the dot. Now, I've got a bit of a problem because if I look at the bigger triangle, if I look at what information I have here, opposite the dot here is 3, but opposite the dot for the big triangle, I haven't actually got that length. Whereas it's the blank side that I have on the big triangle. I've got that whole thing as x plus 5. Lucky for us, you can see here, you recognize that this is Pythagoras' theorem and it's 3, 4, 5 triangle. So I can say that that is 4. Just from my knowledge of Pythag. If you couldn't remember the 3, 4, 5 triangle, we'll use Pythagoras and solve to get that length. And so now, again, if you're finding it hard to see, draw the triangles separately. That's dot. So we've got 3, we've got 4, we've got 5, and when I've got the big triangle, you will now see that we don't have every single side, but this hypotenuse here is x plus 7. So 3 plus 4, don't forget to put your dot in here, and down the bottom, that's x plus 5. So once I start, I'm going to start with these because I've only got 2 options, so it doesn't matter which one, they're both unknowns. So I'm going to go, that's x plus 5 over x plus 7 equals, okay, x plus 5 here, that is opposite here, the blank angle. So blank, that means its corresponding side on the other triangle is 4. X plus 7 is the hypotenuse of this one, so the hypotenuse of this one is 5. So this is a good example where you've got extra information. It doesn't mean you can just guess to put any in. And here we go, we can now cross multiply. So 5x plus 25 equals 4x plus 28. Get that over, so that becomes x equals, and 28 take 5 is 3 units, whatever that may have been, meters, centimeters. So just double check, especially when you see a right angle triangle, that if you don't have a needed side, then you can use Pythagoras. He's so useful. Hope that helps.